Hi kids, so in this video we'll continue with theorems on area exercise 14 from M L Aggarwal. This is class 9. So we have already done till sum number 9. You can click on the I button or check the description box. Over here we'll start from 10. This is 10a. I'll just read the sum. In the figure given below, area of ABCD, this parallelogram, is given as 29 centimeters square. Calculate the height of the parallelogram ABEF. Given AB is 5.8 centimeter. Very easy. First of all, look at ABCD and ABEF. These two are two parallelograms which have the same base AB. Yes or no? And they are between the same parallel lines AB and DE, which means their area will be same. What I'm saying, area of parallelogram, just check the diagram properly. ABCD is equal to area of parallelogram ABEF. ABEF, reason, same base, that is AB, and between same parallel lines, isn't it? That's why the areas are same. Now look carefully. This is one of the theorem we have already done. Okay, I've explained all the theorem. Now area of parallelogram ABCD is given as 29, and area of parallelogram ABEF, suppose FE is the base, and suppose this is your height H, then can I write base into height? Now look carefully. In a parallelogram, the opposite sides are equal. FE is equal to AB. So instead of FE, I'll write AB into H. AB is given as how much? 5.8 into H, which means H equals to 29 by 5.8. That's how much? 5. So that's 5 centimeter. Very easy. We have just used this theorem, that area of two parallelogram having the same base and between the same parallel lines are equal. Done. Now let us look at 10b. Now look at 10b. In the figure given, area of ABD, this one, okay, is given as 24 square unit, and AB, this is given as 8 unit. Okay, you need to find the height of triangle ABC. Suppose this is your height H. You need to find the height of the triangle ABC. Now look carefully. If you look at triangle, area of triangle ABD and area of triangle ABC, they will be same. Why? Because they have the same base and they are between the same parallel lines. Remember the theorem we have already done? Triangles having the same base and between the same parallel lines have equal areas. Why? Because they have the same base. Look over here, AB is the same base. Same base AB and between same parallel lines. Yes or no? In the previous case it was parallelogram having the same base and between the same parallel lines. Over here we have triangles having the same base and between the same parallel lines. So the areas will be equal. So now area of ABD is given as 24. Area of ABC, again we know area of a triangle is half into base, corresponding base, into height. If the base is AB, then the corresponding height will be H, that is CM over here. So this is 24 multiplied by 2 equals to, AB is given to us, 8 into H, 8 one time, 8 three times. So H is 6 unit, which means the height of triangle ABC is 6 unit. Yes or no? Just remember the theorem. Done. Now let us look at 10 part C. Now look at 10 part C. In the figure given, E and F are midpoints of the side AB and CD respectively of the parallelogram ABCD. This is a parallelogram, and E and F are the midpoints. If the area of the parallelogram ABCD is 36 centimeters square, find number 1. State the area of triangle APD. APD. Let me see the diagram. APD. Yes. APD. This area. And name the, we need the area of this triangle, okay? Name the parallelogram whose area is equal to the area of triangle APD. APD. Chalo, let's see. First of all, if you look at, we had a theorem that area of a triangle is half the area of a parallelogram having same base and between same parallel lines. Something like this. Remember? Suppose this is your parallelogram, and with this base, suppose I draw a triangle, APD. Then APD, the area of this triangle, is half ABCD. Yes or no? Actually, this triangle I can draw like this also. If you extend this, look, they should have the same base and between the same parallel lines. Then the area of the triangle is half the area of the parallelogram. Now look carefully at this figure. ABCD is a parallelogram. AD is parallel to BC or CP. Okay. Now ADP or APD is the triangle which has the same base. If this is suppose the base of the parallelogram ABCD, then this is also the base of the triangle APD, and they are between the same parallel lines. Look carefully. This is your parallelogram and this is your triangle. So this was your parallelogram, this is your triangle. So area of this triangle will be half area of parallelogram. Why? Because the base is same and they are between the same parallel lines. So I can tell that area of triangle APD is half area of parallelogram ABCD. Why? Same base. In this case, the base I've taken as AD and between same parallel lines. Yes or no? Which means this will be half into 36. That's 18 centimeters square. Done the first part. Now name the parallelogram whose area is equal to the area of triangle APD. Now look carefully. Dhyan se. E and F are midpoints of AB and DC, and AB and DC are same. Which means, can I say that AE is equal to DF? Yes or no? Because suppose AB was 10, then DC is also 10. E is the midpoint, so A is 5, DF is also 5. They both will be equal, as well as these two will be equal. Yes or no? So if you look carefully, in quadrilateral AEFD, okay, we can say that AE is parallel to DF. Yes or no? AE is parallel to DF and AE is equal to DF, which means AEFD is a parallelogram. Sahi hai? Now we know that if two parallelograms have the same base and they are between the same parallel lines, the areas are equal. Now AE and EB. See, I just proved that AEFD is a parallelogram. AEFD is a parallelogram. Why? Because opposite sides are equal and parallel. One pair of opposite sides are equal and parallel. In the same fashion, I can prove that EBCF is a parallelogram. Same thing. Opposite sides are equal and they're parallel. Yes or no? Now look at AEFD and EBCF. The bases are same and they are between the same parallel lines, which means both the areas will be same. Yes or no? So we can say that, I'll just rub this one. Area of parallelogram AEFD will be equal to area of parallelogram EBCF. Yes or no? If both the areas are same, then we can say that area of AEFD and area of EBCF is half area of parallelogram ABCD, because ABCD is your total figure, you know. That parallelogram is divided into two equal figures having equal areas, which means I can say that, look carefully, area of parallelogram AEFD is half area of parallelogram ABCD, because these two figures have the same area, AEFD and EBCD. Similarly, we can say area of parallelogram EBCF is half, again, area of parallelogram ABCD. That's quite obvious, because the total figure ABCD was divided into two parts having equal area. So one part is half the entire figure. Now look, area of triangle APD is half of ABCD. Area of parallelogram AEFD is half of ABCD, and area of parallelogram EBCF is half of area of parallelogram ABCD. What is the question? Name the parallelogram whose area is equal to triangle APD. So this one and this one, these two triangles have the same area as triangle APD, which means parallelogram AEFD and parallelogram EBCF. Done. This was, you need to think about this one, this property. You need to remember that in a quadrilateral, if one pair of opposite sides are equal and parallel, then it's a parallelogram. Then it's easy. Sure. We'll do number 11. Now look at 11 part A. In the figure given below, ABCD is a parallelogram. ABCD is a parallelogram. Point P and Q on BC trisect P and Q, trisect BC, which means BP, PQ and QC will be equal. Yes or no? Because P and Q trisect means divide it into three equal parts. Prove that area of APQ and area of DPQ, APQ and DPQ are same, and that is equal to 1/6 of area of parallelogram ABCD. Chalo, we'll see. First one is very easy. I'm first taking these two. Look carefully. Remember the theorem. Two triangles having the same base and between the same parallel lines have equal area. See, APQ and DPQ have the same base PQ and they are between the same parallel lines AD and BC. So can I write area of triangle APQ is equal to area of triangle DPQ. Why? Because they have the same base and between same parallel lines. Yes or no? So the areas are equal. Done. Now the second part. Area of APQ is equal to 1/6 area of parallelogram ABCD. If you can prove this, then this relation comes. Or somebody wants to prove area of triangle DPQ equals to 1/6 of this, that is also okay. Now look carefully. ABCD. Let area of triangle parallelogram ABCD is equal to X. मान लेते हैं. Then area of triangle AQD. Just look carefully. Area of triangle AQD will be half area of parallelogram ABCD because they have the same base AD and they are between the same parallel lines AD and BC. If I take AD as the base, yes or no? Which means, can I write this as x by 2? Remember this. So area of AQD is x by 2. Now, area of the whole figure is x and this portion is x by 2. Which means this triangle and this triangle, their areas add to give x by 2 because the total is x. This is x by 2. So the remaining will be also x by 2 because x by 2 plus x by 2. These three will be x by 2 and this is x by 2. They add to give x. Yes or no? अरे पूरा मान लो. This is suppose 100. So if this portion is 50, then these three add to give 50. Yes or no? 100 by 2 is 50. So these three also will add to give 50. Now look carefully. A, B, Q. Now A, B, Q. Or simply, see, area of triangle ABP will be equal to area of triangle APQ. APQ will be equal to area of triangle DQC. Why? Because they have the same base and they are between the same parallel lines. So the areas have to be equal because area is half into base into height. The height is same, the base is same. Base is same, height is same because they are between the same parallel lines. Which means the areas will be equal. Now these three add to give x by 2. So area of APQ, if I want, area of triangle APQ will be the total area of this 3i x by 2. X by 2 divided by 3. Yes or no? Because x by 2 is divided into 3 parts. So that's x by 6. And what is x? X is nothing but the area of parallelogram ABCD. Area of parallelogram ABCD. Isn't it? By 6. Which means, just a second, parallelogram ABCD. See, area of triangle APQ is 1/6 area of parallelogram ABCD. And these two we have already proved. So from this 1 and this 2, we can say that area of triangle APQ equals to area of triangle DPQ equals to 1/6 area of parallelogram ABCD. Done. Very interesting. Remember, if there are triangles which have the same base and they are between the same parallel, equal base or same base. Okay? Same base or equal base, doesn't matter. And they are between the same parallel lines, the areas will be equal. Because the base and the height is same too. Chalo, we'll do number 11 part B. Now this looks like a nice sum in the figure given DE is parallel to the diagonal AC of the quadrilateral ABCD. Now ABCD is a quadrilateral. Don't take it as a parallelogram. But AC and DE are parallel. Okay. DE is drawn parallel to the diagonal AC of the quadrilateral ABCD to meet BC produced at the point E. Prove that the area of the quadrilateral ABCD and the area of the triangle ABE are same. Very easy. Just look carefully. Area of, see the figure carefully, area of triangle ACE, which means this triangle, this area, okay, will be equal to area of triangle ACD. Will be equal to area of triangle ACD. Why? Because they have the same base AC. Same base AC and between same parallel lines. Just look carefully. Parallel lines. AC and D. Both the triangles are between the same parallel lines. ADC, AEC, AC and DE are parallel. Yes or no? Now, same base and between the same parallel lines. Now, over here, what I'll do, area of triangle ACE. Now, I'll add a quantity on both sides. That is, I'll add this portion. Try to understand. I'll mark it with the red of it so that you don't get confused. Blue. I'll add this region on both sides. So area of triangle ABC is equal to area of triangle ACD plus ABC. Area of triangle ABC. Now look carefully. ACE plus ABC gives you ABE. Look carefully. So this is area of triangle ABE is equal to area of triangle ACD plus ABC. That gives you the quadrilateral area of quadrilateral ABCD, and this is what we were supposed to prove, that area of the quadrilateral ABCD is equal to the area of the triangle ABE. We used one property that triangles having the same base and between the same parallels have equal area, and then we added this quantity on both sides and we got the answer. Done. Now let us look at 11C. Now look at 11 part C. In the figure given below, ABCD is a parallelogram. You can see ABCD. O is any point on the diagonal AC of the parallelogram. Okay, show that what we are required to show. Show that area of triangle AOB, area of triangle AOB is equal to area of triangle AOD, which means AOB, this area, and AOD, this area is same. Very easy. Look over here. What I'll do, I'll draw this diagonal BD. Now in parallelogram the diagonal bisect each other, which means suppose this is E, then DE and BE will be same, yes or no? And AE and EC is same. Now look, in triangle ABD, area of ADE, which means this area and this area will be same, will be equal to area of triangle AED. Why? Because AE is the AEB, sorry, AEB. And why they are equal? Because AE is the median. AE is the median, and the median divides a triangle into two equal figures, which means two triangles having equal area. Now in the same fashion, you can say that, look at triangle DBO. In triangle DBO, same way, DE and EB are same, which means OE is the median, yes or no? OE divides DB into two equal halves, which means area of ODE, area of triangle OED will be equal to area of triangle OBE, yes or no? Why? Because OE is the median, and the median divides the triangle into two parts having equal area. Now the last step, just add these two. Suppose this is your 1, this is your 2. When you add these two, what do you get? Area of ADE plus area of OED will be equal to area of AEB plus area of OBE. Yes or no? And this region added to give you AOD. These two added gives you AOD. So instead of this, I can write area of triangle AOD, and these two added gives you AOB, which means area of triangle AOB. Yes or no? Very easy. We have just used that property that the median of a triangle divides a triangle into two equal halves having equal area. Very easy. Sure. In this video, this was 11C. We have already done 6 sums. Keep it till here. In the next video, we'll see the rest of the sum. Till then, take care and be safe. And if you like the video, do subscribe and share.